So let's talk about NURBS. Up until this point, we've really talked about geometric 3D geometry. We've either had a primitive 3D object or we've started with a planar piece of geometry and we've given that depth. So if we want to go and design a building that looks something like this, bonus point, can you name this architect? Or we want to model an object that looks something like this, we're not going to be able to use simple geometric forms. So one of the tools we have at our disposal in Vectorworks are NURBS. All right, so what exactly are NURBS? Well, NURBS is an acronym that stands for Non-Uniform Rational Basis Spline, right? Perfectly clear? Okay, let's break that down. So let's start at the end. So basis spline. If you've ever used one of these in your drafting drawer, or one of these, or if you've ever built one of these, you've actually worked with splines. And splines are actually what we have when we draw polylines in Vectorworks, or in the Adobe suite. If you've used paths, you've actually worked with splines. So a spline is a continuous curve that has various anchor points and control points, and much like taking a strip of wood and clamping it and anchoring it in various spots. So we get that nice continuous curve, but it's not geometric. It's not a circle. It's not a line. It's something sort of smooth based on these points. So rational. This is a bit of an oversimplification, but a NURBS curve is made up of a bunch of rational polynomial equations. So this is an example of a rational equation. There's x to the third power minus 2x, and there's an x squared in there. It's, if you remember to your algebra class, if we have an equation of x's and y's and powers, we can draw things like a line or a circle or an ellipse. We actually can't draw one of these. This is a catenary curve, and we can't make a Fibonacci spiral. For those, we need trigonometric equations and logarithmic equations, but we can actually get a pretty good approximation. So we're able to define all of these shapes with a mathematical function. And then finally, non-uniform. So we don't need to pick one mathematical function for the entire curve. We can actually splice together a whole bunch of mathematical functions. So that's where the non-uniform comes in. And we're not limited to one plane. We can go in the x, y, or z axis as we have this equation. And they all kind of are smooth and nice together. So by combining these different equations and then combining a bunch of NURBS curves into a NURBS surface, you can get all of this free-form geometry. So the number one thing to think about when you're trying to define a NURBS is a NURBS curve is a mathematical curve in 3 dimensions. And this is actually a picture of a single curve from 4 different views, a top, front, right, and isometric view, and you can see that it's twisting and curving in all of these different directions. The other thing to know about NURBS is it's an industry standard. So NURBS were actually developed for the auto industry as a way of defining the contours of an automobile and sharing that among a lot of people. So if you've ever used the software Rhino, Rhino started out being based primarily as a NURBS-based modeling software. So that means if you're transferring NURBS objects from one piece of software to another, it's going to be pretty uniform. There's also a whole body of mathematics that is written about NURBS curves. We're not going to have to delve into any of that for this class, but kind of know that it's a standard way of talking about curves in 3 dimensions. The other thing that it means is because we're dealing with mathematical curves, The amount of information required for a NURBS representation of a piece of geometry is significantly smaller than a faceted, a mesh-based representation. So if we have something like SketchUp that uses mesh, that's actually taking lots of little triangles and compositing those together. And while we can do some processing to make those triangles appear smooth when we do a render, really, it's like the pixel version compared to a vector. So in a piece of NURBS geometry, we can zoom way into that 3D object, and it's always going to be flowing and smooth. That means that if we're doing a realistic render, it's going to take a lot less time to render if we do NURBS, and it means we're not going to have to ever sort of smooth out any edges. It's always going to be a nice, clean 3D object. So let's take a look at actually making some NURBS. So go ahead and open a brand new Vectorworks file in 1/4" scale. So before we start drawing some NURBS, let's look at how we define the NURBS geometry. So spline implies that we define the curve with control points. We also want to specify a degree for the curve, and the degree can be any positive whole number, and usually we're dealing with degrees of 1, 2, 3, or 5 when we have NURBS curves, but really it can be any number. And that degree happens to relate to that polynomial equation we were talking about before. So if we double click on a curve, we can really see what's going on. We have this curve going through control points, and if we look over to object info, we see that this is a degree of 1. So this is a linear equation, and we're getting straight lines. So if we have the same number of control points, and we go to a second degree curve, this is actually a quadratic equation, so we can use this to make things like circles, ellipses, parabolas, any kind of conic section. Then as we go to a third degree, we're softening that curve as it relates to the control point. And then we go to a fourth degree and a fifth degree. We can also look at two curves that have the same geometry. This one is a second degree quadratic curve, but if we increase the degree and keep the geometry constant, we can use that as a way to have the same geometry, but with more control points. So let's look at drawing some NURBS curves. Go ahead and select your 2D locus tool and place 4 points on the drawing in a kind of a zigzag. 1, 2, 3, 4. All right, now go over to your 3D tool set and find the NURBS curve tool. All right, now we're going to switch over to the 3D mode for drawing and go over to your modes. So we're going to do the second mode first in this first group, control point mode. And then click over on the button that's next to that. And this is going to set the degree. So we want to go second degree here. And mode 2 is going to draw by control points. So if we go 1, 2, 3, and double click on the fourth, you're going to see that we're going to get a curve that is tangent to those control points. So now let's do the same thing. Go to your mode bar and select the first mode. This is going to be interpolated mode. And click on the same points. 1, 2, 3, and then double click the fourth. And we're going to see interpolated mode. Vectorworks is calculating where those control points are virtually so that the curve will pass through the 4 points that you've defined. It's interpolating the geometry of that curve. So now let's do one more thing. Go up to your mode bar and change the degree now to first degree. and click those same points again. Now we have our straight line going through those control points. Now there's no curve there, so it really doesn't matter when we have a straight line if we're in interpolated or control point mode. It's going to be exactly the same. If we really want to see what's going on with those control points, we can go to the Reshape tool, and we can either find that over in our tool palettes, or with the Selection tool, of course, we can double-click on a NURBS curve and get to the Reshape tool. And we see here that these two curves have the exact same control points, but the interpolated mode passes through the control points. We can also go over here in Object Info and change the degree. So if we start with a 2nd degree and we go up to, say, a 5th degree, we're going to get more control points. We can actually go less of a degree, so we can go back to 2nd degree, but we can't go past what's mathematically possible. So if we go to 1st degree, it's going to reset here to 2nd degree. All right, I'm going to go back to 5th degree. And if you look at the mode bar for the Reshape tool, we can change a point, we can change the kind of point, and we can add or subtract. So those should be similar from your Polyline tool. You can also see when we move a point, we can limit the plane that we're moving because we're working in 3D. And sometimes we want to be able to take that point and say just go in the Z direction. So we can limit that reshape to just the Z axis. So that's kind of useful. The first mode is going to constrain to the current working plane, which it's currently in the layered plane. So if I now just take one of those vertices and distort that there, and now try to go back to 2nd degree, we're not going to be able to, right? Because now that we've moved this one control point, we have more points, and this is only mathematically possible with a 5th degree curve. We can't get back to that 2nd degree curve. So that's the two modes for drawing control points and the degree for NURBS curves. The next thing to know about NURBS is that each control point can have something called a weight to it. We can almost think of a weight as a kind of gravity. The higher the weight, the more the curve pulls to that control point. So if we look at this example, this curve, if we go over to Object Info, we can use a little arrows to advance through the points. So this is the first point. If we advance to the second point, we see this has a weight of 1. If we go over to this curve, that center point has a weight of 4. So that curve is drawn more to that point. So the weight can actually be any number that's greater than 0. So if we set this to 1, we get kind of a gentler curve here. If we set this to 0.01, we get nearly a line. And if we go the other direction, let's say 99, we get something that looks like it almost touches that curve, a very tight bend there. So in theory, mathematically, we can go higher, but in Vectorworks, we really can't enter a weight too much higher than 99, or Vectorworks gets cranky with the math. So if we want to see a more practical application of weights, go ahead and in your 2D tools, select the circle tool and just draw a circle. All right, now go up to the Modify menu, down to Convert, and convert to NURBS. And we can actually turn almost any shape in Vectorworks into a NURBS curve. So now go ahead and take a look at the weights. So we see that the first one is 1, and then we go to 0.3, and then 0.3, then back to 1, 0.3, and there we go, back to the beginning. So the other thing to remember about NURBS is that we can define nearly anything in NURBS. So we can get a circle, we can get an ellipse, we can get a triangle, we can get this sort of squiggly shape. And sometimes the easiest way to create a NURBS curve is to start with the planar object. I would never be able to remember the degrees and the weights to get a circle from a NURBS curve, let alone an ellipse. It's much easier just to use the tools to draw them and then go to modify, convert to NURBS. One more thing to know about NURBS is a lot of the 2D functions that you can use with polylines and polygons will also work with NURBS. So for example, we can take this and decompose. We can use the connect and combine tool to connect NURBS curves together. We can compose. We can use the split tool to split at a point. We can use offset. We can use chamfer. So we have those at our disposal. Something unique to NURBS is if we select the curve and we want to make that longer, there's really no length parameter, but we can go to Model, 3D Power Pack, Extend NURBS. And here we're picking this point to extend, and let's extend it by 6 inches along the equation of the curve.